Good afternoon. Good afternoon, everyone. Hope everybody's doing great. Everybody's all right. All right. Going to look at 5.3 today. Just waiting for everybody to get in. All right. So it looks like everybody's good. So 5.3, the simple limit theorem. So, and this is the only section we're going to do today. I'm going to save chapter 6 and do that all together. Remember, next week, we're not having class, live class. So what I'll do is just make a couple videos dealing with the first couple sections in chapter 6 and send them to you guys so that we're not losing too much ground. And of course, if you have any questions, we'll pick back up the following week. But also, it'll be hard for me. I'm pretty sure it's going to be hard for me to hold office hours. So, but if you have help, I will be checking emails and stuff like that. And if we have to set up a meeting outside of those office hours and stuff like that, I have to check my schedule and, we'll operate from there. So it is a possibility. It's just that holding those specific office hours may be hard next week while I'm out of town. But I'll send you guys an email reminding you of all that stuff and everything. So the central limit theorem, suppose we take many random samples of size n for a variable with any distribution and record the distribution of the means of each sample. Then we have three things that hold true. So the distribution of means will be approximately, I did APP approximately, a normal distribution for large sample sizes. And so why that's important, we talked about it before, having that normal distribution allows us to use z-scores and the z-score chart. Speaking of which, let me go ahead and pull up z-score chart. All right. If I scroll up and you still copy in blue, let me know. So for the second one, the mean of the distribution of the means approaches the population mean, which is Greek letter mu for all large sample sizes. And we're gonna, do some problems that, will reemphasize what these mean. Right now, we're just writing it out. All right, scrolling up for the last one. By holding on to the green. All right. So the standard deviation of the distribution of means approaches our standard deviation divided by the square root of n for large sample sizes, where the standard deviation was sigma. Remember, that's Greek letter sigma as our standard deviation of the population. scroll up. Let's look at an example that will help us to bring some clarity on those three statements. Anybody holding on to that blue? All right. So this example is called predicting test scores. Oh, hit my hand. So consider the situation. A middle school principal has 100 eighth graders taking a national standardized test with a mean of 400 and standard deviation of 70. That's why. Assume the scores are normal distribution. Rolling up some. What is the likelihood that one of the eighth graders selected at random will score below 375 on the exam? All right, are we done with the black? All right. So this problem is like the problems that we did last class. And the reason why they did one like this, they're doing it in comparison to the next problem, which is B, and showing you the difference between the two, difference in the wording when you would use the central limit theorem, and when you would just use the regular z-scores and whatnot. So this one, you would just use your regular z-scores. You take your mean, take your standard deviation, and then the data value in question, which is 375. And you convert it to a z-score, doing your data value minus the mean divided by the standard deviation, and that'll give us negative 0.36. So don't forget you always round to two decimal places. That's why we have negative 0.36. So the next move is to go to the chart. And that's what I did right here. So remember that negative 0.3 would be here on this left column. 0.06 would be up top. And where they meet is the value that you pull from the chart. And that's 0.3594. All right, any questions so far? Make sure we're okay. All right, so got a question. That's from the chart. So you have to go to your chart. We talked about that chart last class. And it's in the back of your book, page, I believe it's 370, 371. So negative 3 point, oh, where my pen at? Let's see if I do it. Negative 3 point, well, negative 0.3 is right here. And then the 6 is up here. And then where they meet is the value you pull from the chart, which is right here, 0.3594. And so that's how I got that 0.3594. Yep, let me see. Okay, cool. Yeah, but that's the same chart we use last class. Yep, and that's the same chart we're going to use for the next problem as well with the central limit theorem. Yep. All right. So try to write notes about what was going on in the problem. The question asked about below. Remember, it says score below 375. And below is the same as less than. So remember last class, we also talked about certain keywords will let us know what we're dealing with, whether it be less than, greater than, between. Those are our three main scenarios. So this time we have below, which is the same thing as less than. So that means we're going to use the chart value as our answer. All right, so we're okay with the top red. All right, so if you had to put this in sentence form, I saw Math Lab use 36%. I mean, not Math Lab, the book talked about 36%. Well, they got that from this. That's what I was trying to emphasize here. They took the 0.3594, rounded it 0.36. So that's 36%. So there's a 36% chance that a randomly selected eighth grader will score below 375. Make sure we're okay with what we did. Yep, I put score twice. Questions before we go to B? Everybody done with that last statement? So the principal's performance evaluation is based in part on how well her entire group of eighth graders scores on the exam. What is the likelihood that her 100 eighth graders will have a mean score below 375? So what prompts us to use the central limit theorem is the fact that we're comparing a mean. Our data value in question is a mean. Before we just were talking about one score being below 375. This time we're talking about the mean score being below 375. So that's what's going to prompt us to do the central limit theorem. All right, so I'll let you finish writing and then we'll get to it. All right, so if we look at our pieces of information, if you go to, let's go back to our statements of the central limit theorem. And we look at 2, it says that the mean approaches the population mean. And so that just means, right? We're going to use the mean that we have as our mean when we go to do our calculation. So our mean for the whole population is 400. We're going to stick with that. Now, standard deviation, if you go to the third statement, is going to be calculated this way. the population divided by the square root of our sample size. I said population, the population standard deviation divided by the square root of our sample size. So that's what we did here. We took the 70, which was the population standard deviation, divided by the square root of 100, and that gives us 7. And then the mean in question is at 375. All right, everybody okay with that? Once you have those 3 pieces established, you can go ahead and find your z-score. Maybe 375 minus 400 divided by 7. Gives us negative 3.5714, negative 3.57. All right, so you go to the chart, and this chart is a very, I mean, not this chart, but this value is a very low value. It goes past 3.4 and negative 3.4. So there's a statement for something that's this high. It says negative 3.5 and lower. This is the value that you're going to pull from the chart, 0.0001. Which is the 0.01 percentile. You know, if you were to move the decimal 2 places to the right. Mm-hmm. This means that fewer than 0.01% of all random samples of 100 students will have a mean of score of less than 375. So that's all they were asking, what was the likelihood of that occurring? Questions, any questions? All right, can I scroll up? All right, let's do another one. All right, this problem deals with salary equity. So the mean salary of 9,000 employees at Holly Inc. is 46,400 with a standard deviation of 2420. A pollster samples 400 randomly selected employees and finds that the mean salary of the sample is 46,650. Says, is it likely that the pollster will get these results by chance? And then I'll scroll up in a second. So you want to know, or does the discrepancy suggest that the pollster results are suspect? All right, then I scroll up. So mean lets us know, since this is the mean salary that we're questioning, that lets us know we're dealing with central limit theorem. So I mean 46,400, that comes from the population. Then we take that 2420 divided by the square root of 400. And so it's our standard deviation, population standard deviation divided by the square root of our sample size. And that ultimately gives us 121. And the data value in question is 46,650. Convert to a z-score. 46,650 minus 46,400 divided by 121 ultimately will give us 2.07. Excuse me. All right, so go to the chart. 2.0 will be on your left column. 7 will be on the top row. They meet at 98 or 0.9808. So try to use the book's lingo just in case you see it in math lab. So when they look at that 0.9808 from the chart, they say that the standard score lies near the 98th percentile. Move your decimal 2 places to the right, gives you 98% from here. So it's considered lies near the 98th percentile. So this means that the likelihood of selecting a group of 400 workers with a mean salary above 46,650 is about 2%, or in other words, 0.02. That just came from subtracting 98% from 100. Mhm. And that means the mean salary is surprisingly high. So perhaps the survey is flawed. Questions, questions, questions. All right. So yeah, so these were the problems that they gave for this section. Somebody said something. You mentioned you divided 98 by 100. To do what? Just want to make sure I'm clear on when when I at what part, the orange, purple, or blue statement when you said that. Let's see. Is that what you said to get the 2%? No, I subtracted one from subtracted 98 from 100. Yeah. So if it's in percentage, it was 98, 100 minus 98. Yeah. What else you got? Anybody else have any questions? And so, as always, some questions may not show up until you actually try the stuff out, and that's fine. Um, any questions on anything else? Anything before this section? Anything anybody tried? That's something they want to ask. In the chat. All right, great question. I will go to another page and write. I'll scroll up. Is that okay with me scrolling up? All right, so your next test, which should be test 3, is going to have chapter 5 and 6 on it. And so, if I'm not mistaken, that's 5.1 through 5.3. So we just closed out chapter 5 today. 6.1 through 6, I believe 6.5. So we got a little bit to go before we looking at me posting another test. We have these 5 sections of chapter 6 to cover. And that will be one that you would do in Math Lab on your own time. Yep, no problem. Not a problem at all. So, yep. Questions? Any questions? Everybody good at this moment? Just want to make sure everybody okay. Okay. So try to stuff out. See if you get stuck. Um, once again, just email me if you have any questions about anything. As far as next week is concerned. And I will be sending you an email out just reminding you of happenings for next week. And we will go from there. All right. So you guys have a great weekend. Be safe. And I will see you on next class. Thanks. You do the same. Take care. Thanks. You have a great weekend as well. Thank you. Take care.